Greetings everyone! In this lesson, we cover everything you should know in order to correctly import your own models. We will first get an overview of some aspects we need to keep in mind when creating our own models. Then, we will go through the export-import process using the FBX format and understand some key properties to get the best results. I'll be using Blender, a free software, as our 3D creation tool, but the same concepts can be applied to any other softwares. With that being said, let's jump right in. The first thing to keep in mind when creating our own models is to optimize poly count. While polygons are far easier to render nowadays than ever before, we should still try our best to not waste any performances. For film and rendering, you might get away with heavier models. But for games, your projects should run well on low to mid-end systems. This will ensure that your game can be played by the most people possible. So consider baking your details to normal maps when necessary. Bear in mind that Unreal uses centimeters as a default unit of measurement. This works for Blender out of the box, but if you experience scale issues, make sure to correctly set your preferences in your software. For an easier time transforming your model in Unreal, you should make sure your pivot point is correctly placed. The engine will use the object world center as a pivot point, so make sure to place your model wisely. Unreal recognizes materials and treat them as material elements. This can be used to separate different types of materials, avoiding a single complex shader that is hard to manage. Smoothing can also be imported, allowing you to soften or harden your edges. If you used modifiers to create your model, they will be applied when exporting. To get predictable results, apply them before to make sure everything is in order. Because Unreal relies on GPU, models are triangulated in order to be processed and displayed. This can be generated at import, but doing it before allows you to make final adjustments. The engine also supports multiple UV channels. This can be used to create your own light maps or solve creative challenges. Use the Texture Coordinates node to access UV channels when creating materials. Vertex color is supported and is fairly cheap to render. They can be used to add effects and details to materials. If you think about making any type of physics simulations, you will need to consider creating collisions. They are shapes that are constantly monitoring collision responses while simulating. This can be generated at import or it can be custom made. Level of details, or LODs for short, are simplified version of the model used when the player is at distance. Because there is a limit to screen resolution, we don't need to render high-definition mesh for a few pixel square objects on your screen. This process can be done in Unreal automatically or be done manually before. Now that you have checked every requirement, we are ready to export. Before doing so, I have the habit to apply transformations to avoid weird results in engine. You might refer to the delete history command for Maya users. After that, simply select your model and export it using the FBX format. This format works really well with the engine and is very common in the industry. Some FBX options might only apply to your software, but in any case, the default options should work fine if you are not sure. Let's take a look. In the Include category, select the type of object you are exporting. Animation, camera, or lights should be disabled if you are not exporting those. In the Transform category, you can change orientation and scale. This should be left to default. However, if your models are upside down when imported, try inverting the axis coordinates. In the Geometry category, you can apply modifiers at export if you did not, and options to export smoothing information. This should be left to default, but Blender uses the face mode to correctly export for the engine. Next is Armature. That can be left untouched since there is no skeleton assigned to our model, and animation can be disabled since we are not exporting any animations here. Don't forget to choose a path as a destination for your model, and we can now hit export. Back in Unreal, we will now import the model. Create a new folder to place your new model in, and in that folder, right-click in the content browser and select Import to Game. Navigate to your model and open it. You will be prompted with the Import dialog. In the Mesh category, you might want to turn off Auto Generate Collision if you've created a custom one. If not, Unreal will generate one for you. StaticMesh LOD group lets you generate LODs, or you can use the Import Mesh LODs if you have custom ones included in your model. The next property worth checking is Generate Lightmap UV, which will create a UV channel to store baking information. This can also be done manually using a second UV channel. Combine meshes let you merge multiple objects coming from the same FBX file. Next important settings to check out are in the Material category. Here you can choose to create and assign a default material for your model, but I like to turn that option off to have full control. If textures were used with materials in your 3D software, Unreal will bring them if Import Textures is turned on. We're now ready to proceed. Click Import All and let the editor do its thing. You should now see your asset appear in the content browser. However, if there's any issues, Unreal will display a warning message telling you what went wrong. Inspect your model by double-clicking your asset and you will enter the StaticMesh editor. The Details panel will let you choose a material, import custom LODs or collisions, and will give you access to import settings if you changed your mind about some properties. I had turned on the Generate Collision, so to check what the result is, reach the top bar and click on the Collision button. Enable Simple Collision to display the result. Additionally, to take a look at our UV channels, get the UV button to the right of the Collision button and choose a channel to display the layout. The channel used to display textures is typically the channel 0, and the channel 1 was generated at import to display light maps. You can now close this window and drop your object in the scene. After import, you can still go back to your 3D software and make any changes. Just export it again under the same name, and in Unreal, right-click your model in the content browser and select Re-import. And the model will be updated. This wraps it up for this lesson. You now have a better understanding of the whole process, and you should now be more confident when creating custom models for Unreal. In the next lesson, we'll talk about animations and how you can import your own. Until next time, take care and have fun.